So sometimes we're faced with an equation that is just kind of beyond our skill set, right? And this particular equation's a good candidate for us to consider other techniques. And one of the things to look at is the fact that the left-hand side is actually an exponential curve, right? This is 2 times 3/4 raised to the x power. The fact that there is a variable in my exponent indicates it's an exponential. And then this entire curve to shift up 7 units by the plus 7. This other side over here is probably a linear equation. This is 7/10 times 4. So there's a slope, and if I distributed and collected like terms, I could figure out what the y-intercept was. This we understand pretty well, and if we were just dealing with things that look like this on both sides, it would be fine. When we see equations that look like this, it's probably a good indication that we might want to try a graphing technique. So we're going to use the TI-84 calculator here just to attempt to figure out where these two objects intersect each other. And to do that, I'm going to go ahead and go to y equals, and I'm going to enter both of these. Oops, I don't want this menu. Hit y equals, and I'm going to enter both curves. So the first one's going to be 2, and then times, I'll do open parentheses, 3 divided by 4. Oops, 4. I'm going to raise this to the x power, leave my exponent, and then I'm going to kick it up by 7 units. So that's one curve. The other curve I'm going to look at is just simply 0.7 times this quantity of 4x. There's 4 times x plus 38. And then I'm going to close parentheses, and I'm going to kick this curve down 6 units. Now, when I hit graph, it's possible I could see nothing. And I don't see nothing. I see something. So, however, what I am noticing is that although I don't see a point where these two objects intersect, I don't see the left-hand side intersecting the right-hand side anywhere. That's probably happening somewhere off screen. So what I need to do is change my window. And if you look at this, my domain right now is running from x is -10 to x is +10, and that's probably fine. My range is going from -10 to +10, and I want to see more of the range. I want to see values up here. So to change this window, conveniently, I'm going to click window. And again, my x min, x max is fine. I'm going to leave those alone. My y minimum, I could probably leave at -10, but I'm just going to make it up to 0 because I don't think I don't think they're intersecting when y is negative. But I'm going to make this value, I'll try 15 the first time. I may want to go higher than that, but I'm going to give me 5 extra units. Let's hit the graph now and see what we've got. So there's our exponential curve again. And there we go. Now, because I understand exponential curves, right, and how this works, I'm not worried that this curve is going to come back and loop around and touch this again, right? This is the one and only intersection for these equations. So I'm just going to go ahead and find where this point is. And to do that, I'm going to use the calc menu on my calculator. It's right here, CALC, calculate. So I'm going to hit second calc and go down to intersect. And again, the calculator is asking me which curves do I want to find the intersection of. One of them is this exponential curve, and it's selected, right? You can see the 2 times 3/4 raised to the x plus 7. The cursor's on it, so I'll press enter. The other curve is actually this line, right? It's this linear function, and my cursor is on it, and you can see that's y2. The reason why a calculator asks that question is because, again, I could have more than one curve on the screen. This one just has the 2 curves, so it seems kind of silly in this case, but it is necessary. And then finally, it's asking me for an initial guess. So I'm going to move my cursor. I'm trying to find where my cursor is. Let me bring it over here to a positive x. And I don't see my cursor. Let me bring, oh, y is all the way up at 23. Let me bring it down. Oh, I can't bring it down. So let me put x close to negative something in here. I'm used to seeing the cursor on the screen, and it's kind of confusing me that I don't actually see where it's at. So we'll go negative. There we go. Okay, finally there's that cursor. So I'm just going to bring it up. So I typically try to go just slightly left of the intersecting point. And by the way, the reason how I resolved that confusion that I had was I just kept moving until I could see x was negative, because I know it's happening over here where x is negative, and around negative 3.4 is where I'm getting close, and you can see a y value. Now that I've given it in my initial guess, my cursor's right there, that's my guess, I just press enter again, and it tells me, well, these two objects intersect, and I'll write these down. This is what the point should look like. When x is about negative 3. I could say 1, 1 if I wanted to go to 2 decimal places, and y is 11 point, and if I'm going to go 2 decimal places there, I would have to go 9, 0. Now the 0 indicates that, yeah, that's intentional, right? That's a significant figure, because I am rounding to 2 places. Oh, no, 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 I'm sorry. If I'm rounding to 2 places, I'm going to look at that third point, so it's going to be 2.89. There we go, that's better. So this point is where these objects intersect. Let me change the font of that to something nicer. There we go. So around here is where I expect the left-hand side and the right-hand side to intersect. So when this is the value of x, it would make both of these things equal to the same thing. In fact, the thing that they would both be equal to is about 11.89. And actually, if I was to hit second quit, and I typed x right now because that's the last value of x, you can see it's going to put that number up on the screen. Again, I was rounding it to 2 places. So that is my value of x. And if I wanted to check this outside of the graph window, I could hit 2 times, and then I could go 3 divided by 4 and raise that to this x value. I went up and grabbed it, and then I'm going to leave the exponent and then just hit plus 7. And you can see when I do that, it gives me about 11.89. Now I'm not going to do both of the equations, but if I was to enter the second equation, or the right hand side here, it would give me pretty much the exact same value, 11.89. So again, that's how you use your calculator in situations where we don't quite have a full enough tool set yet to solve exponential equations like this. But definitely we can get a pretty good handle on where solutions are likely to be and get very, very good decimal approximations for solutions.